So we recognize this is a transformation of the inverse graph, 1 over x. And we just have to inspect the graph and pick out the values of the parameters, right? And then, or inspect the function up here and pick out the values of the parameters and then just tweak the graph in that way, right? So what are they? What are the values of the parameters? Somebody tell me one. What's A?
4.
Is there a B? No B. What's H?
2.
So HK equals -2, 3. So then this is pretty straightforward, right? What's the point that's mapped by H and K in this case? It's not really, we don't have a vertex. It's not like a parabola. But there's one key point that kind of sets the stage for the whole graph. The middle one, right, where the asymptotes cross. So we go back to, we're going to do this. It's not very convenient, is it? So let's go like this. So we go back to, oh, it's a mess. I don't like this grid very much. Back 2 and up 3. So there's our vertex, right? That's the point where the asymptotes cross. And then A is 4, so what do we do? What's that tell us? Normally, where would be the point to the right, normally?
Up 1.
Right 1, up 1, okay. So this time though, we're gonna go right 1 and we're stretching it by 4. It's positive 4, so we go up, we don't go down. It's not reflected. So we go up 1, 2, 3, 4. So we're right there. And so that's just kind of the one point that we have to give us an idea roughly what that graph's gonna look like. We go back 1, down 4. So about there. And there's our graph. Okay. If we were writing the domain and the range, what's the only excluded value from the domain? Did you get that? -2. Does everybody see that? When we have an asymptote like that, remember the behavior of an asymptote is as the ant walks towards the asymptote, the ant can get, in calculus we'll say, arbitrarily close. There's no limit to how close he can get, but he just never gets to that one value, right? So that's the only value, -2, is the only value that has to be excluded from the domain. What's the only value excluded from the range in this case? 3. Okay, I got another question for you then. How come 3 is excluded? How come? Sam? You're right, 3 is excluded this time. And the answer you're going to give me is sort of right too. Just somebody give me the answer real quick so I can tell you why it's not always true. Well, it's not whole. It's an asymptote, right? We get a horizontal asymptote there, okay? But there is, now you want to be careful extending that logic too far. It's one thing I think that maybe comes up in the book and I just want to address, it's not always true. You can't cross a vertical asymptote, right? A function can't cross a vertical asymptote. That's forbidden. Never happens. It's like an impenetrable wall or barrier. But you can cross, and remember we did an example in here about that. You can cross a horizontal asymptote. So just because it's a horizontal asymptote does not necessarily mean that it's excluded from the range. Okay. You could have, for this function it is, but we could have a different function that maybe did something like this instead. Maybe it goes up, crosses over, and then comes back down or something, right? Like we could have one that did something like this. Does that have any values excluded from the range? It doesn't, does it, right? These two overlap vertically, and so there is no excluded value. So you gotta be a little bit careful with that one. It came up in the book, and when you did the paper, paper and pencil worksheets, I think it asked you about that stuff. And just want you to be aware that, we'll deal with this in much more detail in calculus. Yeah.
Then how are you supposed to know if it can cross it or not?
Okay, it's a good question because we're trying to make a sketch, right? So how do you know if you don't? You kind of, and that's okay. Remember, there's a distinction between a sketch and a graph. Is a sketch meant to be perfect? No, it's not. A sketch is just meant to hit the highlights, right? a lot of times you can get a pretty good idea if it's gonna cross or not based on all the other clues, right? If you know where the holes in the asymptotes and the x-intercept, right? If you know where they all are, a lot of times you can get a pretty good feel for whether it crosses or not. When we get to calculus, we add a lot more ammo to our arsenal here, and then we'll be able to find all the places where there are peaks and valleys, the minimum and maximum. And that usually is enough. But for now, we don't have everything, right? You gotta kind of think of this stuff a little bit as just setting the stage for later better stuff. Yeah.
So when it asks us to graph it or just like sketch it, so we just assume it doesn't cross?
Well, it doesn't really ask you to sketch it. It asks you to choose a graph.
Well, yeah, but what if there's a graph where it does cross?
I wouldn't do that to you. Yeah, I mean, I'm not gonna give you, on each of these, there's enough information for you to tell, and you can always disqualify all of them except one. Okay, I wouldn't give you one where it's ambiguous like that. And if one snuck in there, which I really don't think it did, just let me know, and I'll give you credit for it. Okay, so we're good with that. So this is essentially the same question. We probably don't have to do this whole thing. How could we approach this one? How could we make it the same question? We could just divide this out. In this case, we can use synthetic division. While we're on the subject of that, what if I tweak this ever so slightly? What if I made that like a 2x on the bottom? Would synthetic division make sense there? It wouldn't, would it? Right? It doesn't work. I mean, you could make it work, but it's difficult to do. The rule is, for synthetic division, we only really want to do synthetic division when the coefficient of x on the bottom is 1. What if you had something like this? What if I had a negative on the bottom? Just a what if for a second. Does synthetic work? Or could you make it work?
Yes.
How could you make it work pretty easily? You could multiply top and bottom by -1. Everybody agree? And then I could rewrite this as -4x minus 5 over x minus 2. And now that's great, right? Synthetic would work there, and that makes it a little bit easier. Otherwise, what do you do? If you don't have synthetic as an option, what's long division? Yeah, polynomial long division. Okay, so all we'd have to do here then is just divide this out synthetically. So what's the number in the box? Coefficients 4 and 5. What do we end up getting then? -3. Okay, so see if you can do this in one step. You don't have to, but I think you're at a point where you can do this in one step. Take this result and write it in the in the form of a transformation of 1 over x. So what goes out front? 4. No. The -3 does, right? Okay, we'll go ahead and do it in 2 steps, but then we'll kind of look back and say, okay, how could we have done this in 1 step? So if we write it like this, it looks like 4 plus the remainder of -3, that's what remains over our denominator, x plus 2. But then we could have, in 1 step, what we have to do is to put it in the form a plus 1 over x minus h plus k. The k, this is the k, isn't it? The constant has to go last. So we put our constant last, and then out front, what are we going to do? Well, we want this to look like 1 over x minus h. Well, the x minus h part's good. We got an x plus 2. But we got to factor out the top, which is the -3, right? Okay, what if we had does that make sense? And from there, it's just like the last problem, isn't it? Right? Now we've got an A, an H, and a K, and it's really easy to get a sketch. Okay. For these problems, 8.2 is distinct from 8.1 in that we have much more complicated rational functions, right? We have rational functions that aren't just linear divided by linear. When they are linear divided by linear, though, this is probably the best way to do it. You get a more accurate sketch by doing a transformation of 1 over x than you do by using the techniques of 8.2, right? It's quicker and easier, so it's worth just dividing it out when you can. If I have a linear polynomial over a linear polynomial, simplify the quotient and do it this way, right? What if you had, just a little hypothetical here, What if you had one like this? What if your result, after you divided it out, what if you got this? What if we got negative 5 over 2x minus 3? Say you had to do synthetic division or something, or long division. What's that going to look like? Hang on, that's maybe not quite what I want. Let's do. Let's just make them integers that work. So like that, how about? What am I going to do there to put that in the form of a transformation? I've got k, but how am I going to get my a times 1 over quantity x minus h? How am I going to get this to look like something out front times 1 over x plus or minus some number? Right. Any ideas? Maisie, you got an idea? Okay, I could factor 2 out of the bottom and the negative 5 out of the top, right? What am I left with on the bottom if I factor out a 2? Yeah, x minus 3, right? Does that make sense? Okay, so we got a fractional value of a, but now it looks like the transformation that we want. Okay, questions? All right. Okay, how about this? So now we're moving on to 8.2 style stuff. So this is the one where it's pre-factored for you. Some of the work's been done. What can you tell me about this function here? So how would you approach this if we want to, Sam, get us started here. What do you think? Well, what would you do first?
There's zeros at -6.
Okay, so we got zeros at the bottom and zeros at the top. Make a list of zeros of the numerator, zeros of the denominator, and that tells us a lot. Just having that list tells us a whole bunch of stuff. What's the only zero of the top? Right? Good, -2 bottom. You said we had -6, +1. So what's that tell us then? Where do we have, Drew, where do we have vertical asymptotes then? If the zeros of the bottom are -6 and 1, and the 1 0 of the top is at -2. Yeah, -6 and 1, good. Good, because those are exclusive zeros of the bottom. What about holes? Emily? Do you have any holes here? No, you're right, no holes, because there are no shared zeros, right? Elizabeth, any x-intercepts? Where's there an x-intercept? -2, how come? Okay, exclusive, it's not on the bottom, so exclusive zero of the top would be an x-intercept, right? So that gives us a lot of stuff, doesn't it, right there? If we were to make a sketch then, let's see. So that tells us that we've got a vertical asymptote there, we've got a vertical asymptote there, and we've got an x-intercept there. Okay, that tells us quite a bit, right? No holes. What about a horizontal asymptote? Kyla, what's your thinking about that? Is this going to have a horizontal asymptote? How would we know? Okay, somebody help me out here. Kirk, how do we know what horizontal asymptote? How are we going to know? The horizontal, so the end behavior, the horizontal asymptote. At -2, okay, because you're thinking, what's your reasoning on that? Ratio of the leading coefficient? Okay, but this one's actually, in a way, this makes it kind of harder to find horizontal asymptotes when it's factored like this, doesn't it? Right? factoring it was helpful to find all this stuff, right? But if we want to find the end behavior, maybe this is something we got to do just a quick review on. The end behavior, that has to do with the behavior clear out to the right and clear out to the left. The behavior as x approaches plus or minus infinity, right? What we have to do is now we have to know the degrees of the numerator and the denominator, because that tells us a lot. What are the three possibilities, right? What if the degree of the denominator is greater than the degree of the numerator? What's the end behavior there? Approaches zero, right? So we have, if we said the whole sentence there would be as x approaches plus or minus infinity. If the bottom is a more powerful polynomial, a higher degree polynomial, then the limit's going to be zero, right? So we get a horizontal asymptote at y equals 0 right on the x-axis. So that's option 1, right? What if they're the same degree, top and bottom? Then what was our rule? We take the ratio of the leading coefficients, right? And so that would be also a horizontal asymptote, but it would be at some value other than 0, right? What if the top is a more powerful polynomial, has a degree that's higher than the bottom? Question 1 is, do we have a horizontal asymptote? No, never, right? We never do. I think we need to take a second and review that. Let's do that. I just feel like I don't feel like we're totally 100% clear on that. So let's look at the end behavior. Because I don't want you just to remember. I mean, memorizing that, you're going to forget it. I want you, if you can kind of internalize why the behavior is what it is, it makes it a lot better. So end behavior of rational functions. Okay, so situation 1, we have degree of denominator is bigger. So we have something like, for example, x squared minus 3x plus 1 over 2x cubed minus x plus 3, something like that. What's our rule, right? As x approaches infinity, what's going to happen here, right? We did this a couple ways, but I think the easiest way to remember this is, if we were to write this, well, let's review it. Let's go through the whole thing. So how could we simplify this? If I were to divide the top and the bottom each through by x cubed, what would I get? Right, so that's the biggest power of x. If I factor out an x cubed from the top and the bottom, what would I get? What do I get on the bottom if I factor out an x cubed? That means I'm just dividing the x cubed away from each term, right? So what am I going to get from the first term? 2. Okay, this is a little weird, but what am I going to get from that term if I divide it by x cubed?
1 negative x.
So what is x divided by x cubed? Because when I factor out a greatest common factor, or in this case it's not even a greatest common factor, if I factor something out of an expression, what's left behind, factoring is a process of division, right? I'm just dividing that away from each term.
Is it x divided by
So x divided by x cubed would be 1 over x squared, yeah. Okay, and then finally, if I divide an x cubed out of a 3, that's weird, right? It's not anything you'd normally expect to do. I end up with 3 divided by x cubed, right? So what about the top? Well, x squared divided by x cubed is 1 over x, right? Negative 3x divided by x cubed is minus 3 over x squared. Everybody agree? And then 1 divided by x cubed is just that. So does that make sense? If I factor out an x cubed from both, that's what I get. Okay, why would I do that? Well, here's my motivation for doing that. Okay, I realize I'm going to have a hole at 1, but I'm just going to go, or at 0, but I'm going to go ahead and just cancel those and look at the behavior of what's left behind. If I take the limit now. If I take a limit of f of x as x approaches plus or minus infinity, now we can see what's going on to each term in the top and the bottom. But what's going to happen to every term where I have an x, some power of x on the bottom but not on the top? As x gets really big, what's that do to the fraction? If the bottom is getting huge but the top is not, then the value of the function is approaching zero. Sure. So all of these approach zero, right? So then when we take our limit, what are we going to get? Well, we get the limit on the top, we just get 0. And on the bottom, we get 2. Well, what is that? 0, right? Okay, so there's algebraically how we would show that it's 0, right? Do we really need to do that every time? I don't think so. I don't think we have to go through that whole process. But that's the theory behind it. You can just think of it this way, though, conceptually. If the bottom is a bigger power of x, if you just remember this one thing, and this will stick. If the bottom is a bigger power of x, it's a higher degree polynomial, as x approaches infinity, both the top and the bottom approach infinity, but what's the difference between the two? How much faster is the bottom growing?
The bottom is running really fast.
Infinitely faster, right. And so it still ends up, the fraction still gets pushed to 0. Even though the top is getting infinitely big, the bottom is getting infinitely big so much faster that the value of the fraction still approaches 0, right? Okay, so we end up with, there's case 1. What about case 2? I mean, I'm not going to go through the whole process this time. We kind of reviewed how you do it once. But what if I have same degrees top and bottom? So say we have something like this, f of x equals 3x squared minus 1 over 2x squared plus 7x minus 11. What's the limit of f of x as x approaches plus or minus infinity? Okay, well, you probably remember that it's the ratio of the leading coefficients, but why? How do we, I mean, we could go through the same process. If I divided each of these through by x squared, would you agree that the only thing that's going to go away, or the only thing that wouldn't go away would be the leading terms? Right, I would just get 3 minus 1 over some power of x. I'd get 2 plus 7 over some power of x minus 11 over some power of x. So if we use this same argument, everything's going to go away except the 3 and the 2, right? Another way of thinking about it, and this is all consistent, remember that as x goes to plus or minus infinity, think back to that example we did earlier in the year where we zoomed out on a polynomial. We zoomed all the way out. Remember, the only term that dominated was the highest power of x, was the leading term. So you could even just think of it as being the ratio of those two, right? They're the dominant players when we get really big values of x. And so what is the ratio of 3x squared over 2x squared? That just simplifies to 3/2, right? Okay. And then finally, what's going to be the case, and I don't want to go into detail, we'll do an example of this, but what if we have something like that, where the top is bigger? Just think about this logically. If the top is going to infinity infinitely faster than the bottom, this is never going to, I mean, it's just going to explode, isn't it? Right? As x approaches positive or negative infinity, the function as a whole is just going to go to infinity, right? So it can never have a horizontal asymptote, because that would imply a constant value. That's never going to happen. But if the top is 1 bigger than the bottom, then at least we could get a slant asymptote. At least we know how it's going to go to infinity, right? What's the shape of the function going to be as it explodes to infinity? Okay, and we'll go through an example of those. All right, so back to this one then. Kirk, I'm going back to you. If I multiplied this out, what would the degree of the top polynomial be?
X.
So it'd be 1, right? Okay, we'd get a biggest power of x on the top would be 1. What would it be on the bottom? 2, right? So now what's it going to do? If I took the limit of f of x as x approach plus or minus infinity if the bottom is a bigger degree than the top? It's gonna go to 0, isn't it, right? And we don't even have to multiply it out. We can just look at that and say, oh, okay, well clearly if we did, we know that the bottom really is a polynomial of bigger degree than the top, and so that tells us the behavior. And so then we've got a horizontal asymptote on the x-axis. And so we're almost there. We've got everything we need, almost. We just need to know what's the asymptotic behavior. It's the last piece of the puzzle. Now I'm doing this a little differently. If you read the textbook, they use a little different approach, but I'm doing this for a reason. I want to do this in the way that you'll see like next year and the year beyond. How would we know what the asymptotic behavior is as we approach the vertical asymptote at -6 from the left side? We'll just do one example. If you can do one, you can do them all. So what's going to be, we'll just do this asymptote only. What's going to be the behavior of the function as we approach from that side? How do I know? How would I write out that limit? I'm going to do, take the limit of my function as x approaches -6, right? Because that's the x value we're approaching. But we're approaching -6 from the negative direction, right? Then all we have to do, remember, is just take this factored expression and figure out what the values of each factor are going to be. And that'll tell us the result, right? So what is, so the -2 is constant. That's just plain old -2 always. What is the value of x plus 2? What is the value of that factor? What does it approach as x approaches -6? -4. Okay, what about this guy right here? This is the tricky one. As x approaches -6 from the left, so give me a decimal representation of that number. Okay, yeah, good, -6.000 something, right? So -6 and change plus just plain old +6 gives me a small positive or negative result. Negative. Good, so we end up with a 0 minus, and then finally, that's going to be what, -7? So what's our result going to be? Well, we know because we have the 0 on the bottom and not the top, what's that mean? What's that translate to in terms of an answer? If I take a number divided by 0, it's undefined. It's undefined because it's infinite, right? So we know it's infinity. 0 on the bottom and not the top. That means we're getting this infinite behavior, but we just got to know which direction, positive or negative. So what's the rule here? You got 1, 2, 3, 4 negative, so it's positive infinity. So from the left, we're doing that, right? You get the idea? Okay, there is something else for you guys. I wouldn't normally do this, but think about this. I want you just to just think hard for a second here about this. And you may not remember this completely, but having gone through this thought process once, it'll be easier in the future. Okay, because what if we want to do the other side of this asymptote? This is a pretty cool line of thought here. What's are the behaviors of the factors other than the x plus 6? They're not going to change, are they? Because I'm approaching the same x value. Everybody agree? Whether I'm approaching from the left or the right, I'm still approaching an x value of -6, right? So that guy, and that guy stay the same. Agreed? Okay. What's going to happen here, though, with this one? It's going to be the opposite. So what does that tell you for sure is going to happen? Yeah, if I'm just changing one negative sign, right, then that means I'm going to change the sign of the overall product, right? And so we can guarantee that it's going to go from this side, right? Okay, in what case would it maybe not do that? What would have had to have been true for it to have gone to positive infinity also? How could we have had a situation where this factor didn't change signs? Anybody think of an example of how that might have happened? Because that would have been what we needed, right? We would have needed for the signs to have stayed the same the whole time, whether I approached from the left or the right. Can you think of an example of a factor that is going to have the same value whether it's a 0 minus or a 0 plus? What?
It's squared.
If it's squared. Yeah, or taken to any even power. You see that? What if in our original problem, this had been the quantity, what's that color? This had been the quantity x plus 6 squared. Any real number squared is positive, right? Or is at least non-negative. Agreed? So then if it's squared, we would have known that the behavior would have been like this instead. Everybody see that? Okay. Just kind of, I mean, it's not like that's a pretty high level topic, but think about that one a little bit. I mean, that's something you can, the more of those little tricks you get, the better off you are. Okay, so we could finish this one up just by doing the same process. How about this one? What's the only difference with this guy? What are we going to do to this one? We'll just kind of talk about what our strategy would be. What are we going to do? We're going to factor it out, top and bottom, find zeros at the top, zeros at the bottom. Otherwise, so in that aspect, it's the same as the one we just did. What about the horizontal asymptote this time? What are we going to get? We're going to get -3, right? So we get a slightly different horizontal asymptote. Factoring the top. We need a little review of how we factor the top of this. What would the first step be in factoring the top here? Divide out a -3, okay, and then go from there. Okay, good. So I think we're good on that. I think we're fine with that one. Okay, what about this? I think this is the last.
We have a minute.
All right, we're good. We're good for today. Yeah, so Monday we'll wrap up the review of. I'll put the chapter 9 practice test up.
Well,